Okay, and so today's lesson, today's objectives will be the applications of the law of conservation of energy, specific heat, calorimetry, and then we'll do our lab in determining the specific heat of a metal. All right, so let's go to the lab procedure and I'll show you how to set it up. All right, before you come to lab, make sure you have a copy of the lab notes and procedure here. Okay, so I'm going to go over the procedure with you briefly, but you have it here while you're doing the experiment. We're not going to do the heat of solution part. We'll do the heat of fusion experiment after. Okay, so before you start your lab, here is the data sheet. All right, so make sure you have a copy of it. All right, so let's get started. All right, now we're at the lab portion, so I'm going to show you the equipment needed and the setups for you to successfully do your experiment. All right, so what you'll need to get started in today's lab is first, but not least, make sure you have safety glasses on at all times when you're doing your experiment. Gloves for this lab are optional, but if you'd like to wear them, you may. All right. You will need a ring stand, a ring clamp, a wire gauze which is not broken, so make sure it's in good shape. All right. Thermometer clamp, a Bunsen burner, a striker to light your burner, a large beaker, 600 milliliter will work well for this lab. All right. You'll need two thermometers, some string. This will be your calorimeter, styrofoam cup. All right, make sure one side has a hole in it. All right. You'll need a ceramic tile here to put your hot stuff on. Electronic balance, some paper towels, and some gloves. All right, these are hot gloves, so you handle hot substances. So, all right, and last but not least, your metal to do your analysis, determine the specific heat of this metal. Okay, so now we're going to set up the experiment. Before you get started, make sure you have your safety glasses on at all times. All right, so the first thing you want to do is make sure your ring stands on a firm surface that's not tipping or unstable. All right, so put the ring clamp on to your stand, make sure it's tight. All right, put your wire gauze on there like that. Okay. All right, so you want to maybe, next step, you want to fill your beaker at about 350 or 400 milliliters with tap water is fine. Doesn't have to be super exact, just somewhere around there is good. All right, and then what you want to do maybe is just to promote smooth boiling, use some a pinch of boiling stones. All right, you don't need a lot, just that is good. Just throw some boiling stones in there. All right. All right, and then the next thing you want to do is put your beaker on top of the gauze there. Now, for safety purposes, if you want, you can secure this with another clamp, but this will be all right since our wire gauze is in pretty good shape. Okay. So then what you want to do next is put your thermometer clamp on. The next thing you want to do is take your thermometer, make sure it's not broken. All right, put it in the thermometer clamp. If it doesn't clamp, set it like that. Make sure the thermometer is about halfway in the liquid. You don't want it sitting down too low or too high, so that's about the right level right there. Okay, the next thing you want to do is take your metal piece. All right, and first write down what it is, or if it's an unknown, we'll write that down. All right, so make sure the balance reads 0. All right, put your metal piece on the balance, wait for it to stabilize. Okay, and record the mass once it stabilizes on your data sheet. So. Okay, so you're going to write down the metal that you have here. So we're doing copper today. All right. If you're doing an unknown, make sure you write the unknown number. All right, and the mass that we recorded was 57.954 grams. Okay, so make sure you follow proper significant figures and put your units. Make sure the balance reads 0 also when you're finished using it. Alright, after you've weighed your metal piece, take a piece of string, maybe about 1 foot long, cut it. Alright. Alright, and then you want to tie the metal, the string onto the metal bar. Like this. That makes it easier then to take out of the hot water after a while. Alright. So just make sure it's snug. Alright. Alright, and then what you're going to do is transfer the metal into the water. Alright. And just wrap the string around so you don't catch it on fire when you burn and you light the Bunsen burner. So, okay. So it should look like that. Okay. All right. Next thing you're going to do is get your burner. It's actually a good distance. So before you put the water on, you might want to make sure you got about that much distance between the burner and the beaker. Okay. All right. All right. Again, before you use the burner, make sure the burner, everything looks good on it. It's not broken or anything. All right. Everything turns well. Okay. All right. So, all right. All right. So turn on the gas. All right. All right, turn the bottom, the needle valve, until you hear the gas flowing. All right, and then light it. All right, and remember you want to turn the barrel here to let air into it so that that's a good flame right there. All right, so you can see if I zoom in on it, that's the kind of flame you want. It's got the blue inner cone and it's noisy. All right, those are the requirements. All right. So now what we have to do is wait. So while you're waiting for that, we're going to do the next part of the experiment. Okay, now next you're going to weigh the empty calorimeter with the top and record the mass on the data sheet in A3. So the mass that we measured was 3.070 grams. Okay, and then fill the calorimeter about halfway with DI water and record the mass in A4, and that was found to be 105.323. Okay, here the mass of the empty calorimeter plus the top was 3.070 grams. Okay. And then the mass of the calorimeter plus the water was 105.323 grams. Okay. So again, make sure you have proper sig figs and units. Okay, next thing we're going to do is steps A5 and the rest of that part. So let's move on to that. Okay, what you want to do next is get another thermometer, make sure it's not damaged, all right? And you want to put your thermometer in the hole here, all right? So gently swirl the water inside the cup like this. Do not use the thermometer as a stirrer, okay? And then what you're going to do is just lift it up, all right? And take a initial temperature reading to 1 decimal place, all right? So it's okay to quickly, or if you want, you can just kind of lift it up a little bit. Make sure it stays in the water while you're reading it, okay? So record the initial temperature of the water on your data sheet. Okay, the initial temperature of the water inside the calorimeter was found to be 23.0 degrees Celsius, okay? So So when you're doing your temperature, make sure you record your temperature to 1 decimal place and make sure you put the units of degrees Celsius. Okay, the heating of the metal usually takes about 15-20 minutes. All right, in the event of lab safety, since you are heating things with a Bunsen burner, if something should happen, if something should catch fire or whatever, turn the gas off here at the source. All right, but for the meantime, we'll just keep an eye on this and wait for it to boil. All right, so the heating of the metal here takes about 20-25 minutes. Just make sure you leave it in there so it gets good and hot. All right, and I have to get ready for the next step. All right. All right, so turn off the flame and quickly transfer the hot metal to the cup. Try not to spill any water. It's okay to drop the string in. All right. Okay, so gently swirl the cup like this. All right, and take a temperature reading. All right, watch the temperature. All right, don't use the thermometer as a stirrer. All right, so just keep swirling the cup. All right, keep an eye on the temperature. All right, and once the temperature doesn't reach any higher, you're going to record that as your final temperature. So. Okay, the highest temperature recorded will be the T final, temperature final. Make sure you record the temperature to 1 decimal place in degrees Celsius. Okay, so remember in this experiment, the heat lost equals the heat gained. Right? So the hot metal is transferring the heat from the metal to the water. Okay, and we're going to need that, do the calculations to verify that. So. But in the meantime, let everything cool down, and once things have cooled down, clean up your work area, and then we'll be done with this part of the experiment. All right, so when you're finished with the experiment, you're going to start taking things apart, dry things off, disconnect the burner. This here is going to be really hot, so you might want to take some gloves here. Right. Or if you want, you can let it cool down later. Doesn't matter. Right. Just take that off. Dump the water in the sink. Right. This stuff here will be hot, so just take it off. All right, now please put back all these supplies where you got them from, and then you're done. Oh, before I forget, all right, yeah, this water here too. Just take the thermometer out, dry it off, and dry off your metal piece. This water can go in the sink. Right. That's pretty much it. So just back your supplies where you obtain them, and just clean up your lab area. If you spilled any water, wipe it out. Okay. Now you've successfully completed the experiment in determining the specific heat of a metal. Collected all your data, temperature data, mass data. All right, so I'll show you how to do the calculations next. So this lab will be due next week. All right, so make sure you show all your work, pay attention to units and significant figures. And if you have any questions, please don't hesitate to ask. I'll be around to help you at any time. All right, so have a good day, and thank you for watching this video. Here's our data sheet. So here we have the identity of the metal. In this case we use copper, the mass of the metal, the mass of the empty calorimeter in the top, the mass of the water calorimeter in the top, our initial water temperature, the boiling water temperature, and this was our final temperature, the highest temperature that was in the calorimeter after we dropped the metal piece in. Okay, so now we're going to do the calculations. So very important for full credit on your lab, make sure you show all work, all right, all steps. Pay attention to significant figures and units. Okay, so here we have the mass of the water inside the calorimeter. So you take the total mass minus the mass of the empty calorimeter. Right, so that gives us this number here. Okay, 102.253. Next step, we want to report the change in temperature of the water in the cup. So 27 minus 23 is 4.0 degrees C. Okay. Then we use the specific heat equation to solve for the number of calories. So the specific heat of water is 1 calorie per gram degree C. Here's our mass of the water inside the cup, and here's the temperature change. So when we do the math, this is what the calculator shows. All right, so you want to make sure you round off the proper significant digits. All right, so the calculation is limited by 2 significant digits, so we're going to round that off to 410. All right, no decimal. All right. All right, so remember, heat lost equals heat gained. All right, so the water is gaining 410 calories, and the metal is losing 410 calories. Right, so these numbers are equal. Right, heat is transferred from the hot object, the metal, to the water. All right, so let's move down on our calculations here. All right, so the next step you want to do is measure the temperature change of the metal. So the metal was in the boiling water, which was at 99 degrees. All right, the temperature in the calorimeter was 27, the final temperature. All right, so subtract those two, you get 72.0 degrees C. Okay, then we rearrange the specific heat equation to solve for the specific heat of the metal. All right, so in rearranging that, the calories go on the top in the numerator. This is the mass of the metal in A2. And that's the temperature change. So if we do the math, you'll notice that the units will not cancel, and that's our specific heat units. So in calories, the specific heat of the copper was 0.098 calories per gram degree C. And again, we want 2 sig figs because this was only 2 sig figs. All right. All right. Now you want to look up the specific heat in the literature and see how it's reported. So I use the CRC Handbook of Chemistry and Physics. Make sure you properly cite it in your bibliography. Here I just wrote it down just for reference. Okay, so the specific heat for copper in the CRC handbook is 0.394 joules per gram degree C. All right, so you want to make sure your units are in joules. All right, so we're going to do this conversion. All right, 0.098 calories times the conversion factor for joules and calories. So that's 4.184 joules per 1 calorie. All right, so that gives us these units. All right, again, so whenever you're doing comparisons, you always want to make sure the units are the same. Okay, and then finally, we want to calculate our percent error and see how well we did in the lab. All right, so remember, percent error is the experimental minus the actual divided by the actual absolute value. Okay, so it doesn't matter if you put the actual first, but I always write it like this. So experiment minus actual divided by actual times 100. And so our experimental was 0.41. All right. The CRC handbook literature value is 0.394. And then it's 0.314. Okay, so then we express our percent error as 4.1%, which is pretty good. If you can get under 10%, it's good. If you're under 5 is even better. So I think we did a good job on this lab.